Look at everything around you. I mean, literally everything. Every star, every planet, every galaxy humanity has ever observed. It all makes up barely 5% of reality. The remaining 95%? It's a completely hidden universe, a phantom realm that we can't see, touch, or directly detect. Scientists call the biggest physical chunk of this hidden world dark matter, and without it, the cosmos as we know it would literally tear itself apart. Today in this explainer, we're investigating the greatest unsolved detective story in modern physics. So, for centuries, human astronomy was bound by a pretty simple rule. If it exists, it shines, reflects, or blocks light, right? We mapped the night sky believing those brilliant points of light told the complete story of the cosmos. But as our technology evolved and our telescopes peered deeper into the void, a chilling realization emerged. The math just didn't add up. Galaxies were spinning with this chaotic speed. Stars were changed to orbits that completely defied visible logic. It was as if an unseen architect was pulling the strings, quietly dominating the universe right from the shadows. Okay, let's dive into this. The scale of this cosmic blind spot is just staggering. Everything you have ever known, oceans, mountains, humans, planets, and the billions of luminous stars scattered across the sky, accounts for a mere 5% of the universe. The rest of the pie is divided into two deep mysteries. About 68% is dark energy, which is this enigmatic force driving the expansion of the universe. But 27%, which is more than 5 times the amount of ordinary matter, is dark matter. And that 27% is our absolute focus today. It is a massive, invisible weight that is literally shaping reality. Now, the name dark matter is literal, but honestly, invisible matter would probably be a much more accurate title. We are talking about a mysterious substance completely decoupled from the electromagnetic spectrum. It doesn't emit, reflect, or absorb light, rendering it entirely imperceptible to even our most technologically advanced telescopes. We can't photograph it, we can't bounce radar off it. The only reason we know this phantom mass exists at all is because of the one fundamental force it cannot hide from: gravity. We know it's there because it pulls on the things we can actually see. Let's move to and see how this builds. The very first major clue in this cosmic detective story was uncovered way back in the 1930s. There was a brilliant, kind of eccentric Swiss astronomer named Fritz Zwicky, and he was studying the Coma cluster. That's a massive group of over 1,000 galaxies locked together in space. Well, as he meticulously measured their velocities, he stumbled upon an impossible anomaly. The galaxies at the edges of the cluster were moving with terrifying, inexplicable speed. They were zipping around so incredibly fast that the gravity from their visible stars couldn't possibly hold them together. According to the bedrock laws of standard physics, based on the visible mass within those galaxies, the cluster should have violently ripped itself apart. There simply wasn't enough visible matter to generate the gravitational glue needed to hold them together at those breakneck speeds, so Zwicky deduced that a colossal amount of unseen mass, which he dubbed dunkle materia or dark matter, was anchoring the cluster. Now, at the time, his peers largely dismissed the idea. It sounded like science fiction. It would actually take decades for the scientific world to realize he was absolutely right. The undeniable proof finally arrived in the 1970s, spearheaded by astronomer Vera Rubin's groundbreaking observations of galaxy rotation. And this brilliantly illustrates the problem. Think of a playground merry-go-round. The physics of rotation dictate that objects on the outer edge should move slower than those near the center, right? But Rubin found that galaxies completely ignore this rule. Stars on the extreme outer edges of spiral galaxies are whipping around just as fast as those near the dense galactic core. This rapid, uniform rotation is physically impossible unless the entire galaxy is encased in a massive, invisible halo of extra matter. Fast forward to today, and we have an even more spectacular tool to map the invisible: gravitational lensing. Predicted by Albert Einstein's theory of general relativity, it turns out massive objects actually warp the fabric of space-time itself. They bend the light from distant galaxies behind them, acting almost like a giant cosmic magnifying glass. By carefully measuring how this light distorts and bends as it travels toward Earth, astrophysicists can calculate the exact mass of the object doing the bending. And time again, the math reveals something astonishing. There is vastly more mass bending the light than the visible galaxies can possibly account for. These immense gravitational footprints tell us that dark matter isn't just some localized anomaly. It forms an unfathomably large, invisible web stretching across the entire universe. Normal matter is merely pulled into the densest pockets of this web. Without dark matter's gravitational scaffolding, gas and dust would never have clumped together in the early universe. Stars wouldn't have ignited. Galaxies would never have formed in the first place. It truly acts as the invisible skeleton of the universe, silently holding the cosmos together across billions of light years. It's just mind-blowing when you really think about it. Now, what's really interesting about this slide is that despite this overwhelming gravitational evidence, the most agonizing question remains: what exactly is it? The leading theories suggest dark matter consists of exotic, undetected subatomic particles, often referred to as WIMPs, or weakly interacting massive particles, or perhaps these ultralight particles called axions. Alternatively, some physicists argue we don't need new particles at all, but rather an entirely new understanding of gravity itself, a theory known as modified Newtonian dynamics. Right now, a global scientific race is underway. In highly shielded deep underground laboratories, massive detectors are waiting in complete silence, hoping to catch just a fleeting interaction with a single dark matter particle. So, the crucial point is, perhaps the most humbling realization here is that nearly a century after Fritz Zwicky's initial discovery, the mystery remains entirely unsolved. We can map its effects. We know it dictates the birth and structure of galaxies. We know it acts as the unseen choreographer of the cosmos. Yet its true identity totally eludes us. Every new piece of data seems to peel back one layer of reality only to reveal a deeper, darker puzzle. It's a stark reminder that despite all our immense technological leaps, the universe is far stranger and far more vast than it appears. Somewhere out there, drifting through the invisible darkness, are the answers to questions we haven't even learned how to ask yet. So, I pass the question to you. What do you think dark matter really is? Are we on the verge of detecting a brand new particle? Or is our fundamental understanding of physics profoundly flawed? Let us know your theories in the comments below. If you enjoyed this explainer, please don't forget to like, subscribe, and join Curious Orbit for more deep dives into the greatest mysteries of the cosmos. Until next time, stay curious.